G'day there, you're watching the Aussie BIM Guru, and today we're going to be running through a third part of a family series tutorial session I've been running. We've done two parts prior, so I recommend you watch those first if you haven't already. But without further ado, we'll get into the session. So we're looking today at parameters, formulas, and coding in Autodesk Revit families. So previously we've looked at planning out the family, and we've also looked at reference planes, geometry, and constraining a family. But today we're going to be looking at the third part. So I've sort of broken it down more simply to the 4 stages of building a family: the methodology, the framework, the system, which is today's focus, and finally the polish. So today's session we're focusing on is parameters, formulas, and coding applied to our previously created geometry. So where we're at currently. So currently we've built a family based on an IKEA table. We've got geometry, we've assigned dimensions to the reference planes that are holding the family together, but there's no parameters yet that actually add the intelligence to this family. So we started off with a framework or a skeleton to the body per se, and now we're adding the brain, we're adding the smarts, so the brain's behind the operation. So there's a lot of types of parameters when we talk about parameters in Revit, so it's important to understand all the types and uses and use the right ones for the right functions. So some common ones you can see here are text, length, area and volume, materials, yes, no's, or sometimes what we call booleans, and some other lesser used ones such as family type. It's critical to understand the difference between type and instance parameters, which I will refer to during this tutorial quite a lot. But I guess fundamentally the big difference is that type parameters set here are set at the family type level. So when you swap between types of that family, those parameters will toggle as well based on which type you're using. However, instance-based parameters are set at the family instance level, so each placed version of the family can actually be different from one another, regardless of what type you select off the family. So it makes sense when you sort of spell it out based on the wording, but I found that people usually struggle to comprehend this at first, and I will sort of show you the difference between the two parameters at the end of this tutorial as well. So we're going to use some common parameter types today. So we're going to use length, which we'll typically use for the dimensions of the element. We'll use text for coding, material parameters for finishes, and yes, no for the ability for the table to fold. We're actually going to do the table fold in the next session, but it's just here as an example of something we will cover later. And I have got a video that I used earlier to demonstrate how to use shared parameters, because I will be using shared parameters today. So if you do need to figure out how these work, I recommend you watch this first as well. So we're also going to use what's called nested parameters a few times today. So basically that's a parameter that's being pushed down to the next level of a nested family, typically controlled by this box on the end of a parameter when you select a family. So you can see here, for example, I'm nesting a material parameter down to the leg of a table in this case. So we're going to look at some useful formulas as well to add some smarts to our parameters today too. So I've got some examples up here just for some very common uses for formulas in Revit in families. So basically in a family type dialog in Revit, you have the parameter, what its value is, and then you can drive it with a formula if you so choose. The most basic formulas are locking formulas, so saying that something is always equal to a meter. It's sort of like Excel. Equal implies the formula, and you don't have to write out the equal sign. You can lock values based on other values as well. So you can see here that this one is being locked based on another parameter. You can lock trues or falses. It's pretty rare that you'll need to, but if you do, basically just put in a statement that's either false or a statement that's either true, and it will basically tick or not tick depending on whether it's true or false. And you can lock text using apostrophes as well, similar to Excel. There's some more complicated formulas on display here on the right. So the first one is that we are setting up what I'd call a bad parameter name. So this will be a name that has something like a multiplication sign in it. So Revit wouldn't understand how to deal with that parameter. But one way you can handle that is putting square brackets around it when you reference it in a formula. The next example we're going to check is just controlling a yes, no using a statement. So we're saying, does this, is this greater than 500? If it is, then tick it on, otherwise tick it off. And you can see in this case that this is 0, so it's off because it's not true. Likewise, we can also just say the opposite by using the statement not. So we're saying this is not that, so it's on because this is off. This is really useful for things where you've got two controls visibly of what you want to show. And then you can do or and to collect multiple if statements or multiple conditions to use other formulas and use more visibility controls in your family, which might be something that's on sometimes, but not all the time, but maybe in 2 cases it is, in 1 case it isn't. You could use an or an and you can obviously nest these as well. You can put statements within statements, so it can get quite complicated. And then the last one is basically just an if formula. So if this greater than 500, big, otherwise small. I could likewise have also said if example and yes, no, and use that parameter there instead to nest this statement as a formula. So just some examples of formulas in use there, and we will use some basic ones today. And you can see just the formulas can get quite complicated. So this is an actual family I've built in my professional work. And you can see just the sheer amount of formulas driving this family. Some are locks, some are formulas with arithmetic. Some of them are if statements, some are nested if statements. So it can get very complicated. But obviously this is a very special family. That was a very complex facade panel I was building. Okay, so we're going to look at coding systems today as well, right at the end. How to classify a family. So there's 2 methods we'll use today. One is assembly codes or the uniformat system. This file is located in this path on your computer most likely, whichever version of Revit you're working in. I'm working in 2019 today, but other versions might have it as well in the same location. So you can see that the way the system works is it basically has a class system, and as you get further in, more and more numbers get appended on the end as you get more specific about what you're specifying. So you could stop at E20, for example, or you could even stop at E. It's just a way of classifying elements, and it's very common. And the other one is omni-class, which is less common, but still good to put in your family as well. So this is table 23, which refers to products. You can read more about it at the omni-class website, but this comes with Revit. It's in by default, and it's basically another way of classifying elements. And it's more to do with procured elements such as tables, chairs, furniture, electrical equipment, rather than walls and doors and ceilings, for example. So you can see here how I've managed to specify a coffee table by going down through the levels. But anyway, without further ado, let's actually apply some parameters to our family. Let's do a demonstration. So this is where our family got to last time. It's basically just a simple 3D family on the surface, a bunch of extrusions, revolves. We had a nested leg that is another family, 1 level down. So we will add some parameters to that too. But in principle, everything in the family has been locked down with dimensions at this point. Some dimensions were left flexible because we were going to apply parameters to them. But in principle at the moment, everything is constrained. So we've left some major dimensions, width, depth, and height. If I want to add a parameter to this dimension, I just go up here. Previously it used to be here in the older versions of Revit, but in 2019 it's in the ribbon now. If I go create parameter, I can either make a family parameter or I can make a shared parameter. So I could add width here, but instead I'm just going to go to make a shared parameter as well. And I'm just going to browse to where that should be. So this is my shared parameter file that I use for my personal work. You're welcome to build one as well. So I'm just going to pick a width parameter, and I'm going to make it a type-based parameter because I want this to be a type-driven parameter. And I'll group it under dimensions. You can group it under any area that you like, technically. But usually most of them go to the right spot by default. You can see that it's always a length parameter. That's because the shared parameter is defined that way. So if I go here and then I go to my type properties up here, you'll see that now this is a parameter that's available. And if I change this parameter to say 700, notice my family flexes now because I've added that ability. And because I've set up my constraints to work in particular ways, it will work now in that manner. Likewise, we can also add depth to the family too. So we'll just add a shared parameter for that. And we'll also add height. Great. And you can see eventually this becomes quite an intuitive process, quite quick. And we'll also add a countertop height. But with this one we'll make a family parameter just so you can see the difference. I'll just call this counter thickness. If I go to my type properties, you'll notice this is a non-shared parameter at the moment, but these are all shared. So these would all be schedulable. This would not be schedulable, but that's probably okay. And what we'll do is we'll just lock that down to 20 with a formula. Okay, so let's change the height of our table. Let's make it 900. Great. So this family hasn't grown. You'll recall that we actually made this a nested family previously. So what we actually need to do is go in and add an additional parameter to this family. So we need to add a height parameter. And we're not going to use a shared parameter in this case. We're just going to call it height, and we're going to make it type-based. That might seem a bit strange, but you'll recall that we didn't make this a shared family. So because these won't reach the project, Revit actually lets you nest instance parameters into type properties of families if they're components, as implausible as that seems on the surface. And you'll see now that if we change that parameter, it now pulls the family with it. We've got to be careful. Sometimes these constraints won't always work if you just manually move things around. Sometimes they do, sometimes they don't. See there? So usually you need to use parameters to pull these because Revit does naturally move this geometry itself the way it thinks it should be done. And while we're here, we're also going to add a material parameter to the leg. So we're just going to nest this parameter into the geometry. So we're going to make a new parameter, a shared parameter. Actually, this one I won't make shared just so you can see how you could do it without a shared parameter file. And we'll just call that finish. I'll make it type-based, materials and finishes. It knows it has to be a material parameter. And we'll load that into the project and close. So we'll load this back in the family. Okay. So now there'll be a couple of parameters available at this level. So we've got a finish for the leg, and we have a height for the leg too. But what we're going to do, if we make this height, you'll see it goes up to the table surface. We actually want this to be that minus the table surface. So we're going to nest in the type properties of this leg a formula. Also note that the parameters in the family don't come through to the next level. You have to create that parameter again in its host. Okay, so leg height is equal to height minus counter thickness. There you go. And sometimes with these, I'll have to put them under other, just so that they're out of the way. So things that are locked down or not able to be controlled by a user are sort of moved away, and it's much cleaner to work with the family. Okay, and there you go. And you'll see that if I go back and I change that table height, 730, you'll see the legs go back down again because they're controlled by the formula. So as they change, so does that field as well. I'll just set default elevation to 0. Okay, so I could take every parameter in this family and technically change it to get lots of different sizes for the family. I just noticed my drawers growing a bit strangely as well. I might just constrain that in the opposite direction. I might always make that the same distance from the edge of the table rather than the center. Okay, so that's nice and easy. So now we're going to apply materials to everything as well. So we've already put a material parameter in our legs. So what we might do is just nest a material parameter into here. And I'm going to use shared parameters for these just because you may want to schedule your finishes in a project potentially. So I keep my materials under general. I'm just going to make these material 2 because material 1 I'm going to use for my countertop. I'm going to make it type based, and then I'm just going to hide these so that I can marquee all my geometry. Because if I select my legs and my geometry at the same time, you'll see I don't have the ability to put formulas into those elements because they're not working at the same level. But if I do this with all my geometry, then there we go. So we're basically going to apply material to everything except for the countertops and the handle. So this is going to be that same material parameter, and then my countertops will be controlled by another material parameter, material 1. But what we're going to do is we're going to make this an instance parameter. Let's say we want people to be able to select the countertop finish on an instance basis instead of a type basis. Great. And then we're just going to apply a third material to our handle, just to make it a brass handle. We'll make that type based. Okay. So currently you'll notice that everything is still just plain and ordinary. So what we need to do now is actually, we might make a type name before we apply our materials. Usually my type names for these sort of elements, if it's going to be more than one size, I will usually call it its size. So 780 deep by 730 high. Oops. Great. In this case, this product only comes in one size, but we're just going to pretend that it comes in more than one for the sake of this tutorial. So what we'll do is material 2, we're going to pick a timber of some sort, or a wood. So you can just search for the material in the browser. It can take a little while sometimes, depending on how many materials you're searching through. And we'll just go to wood. So basically it's finding everything that has I guess a keyword present somewhere in this system. But what we're going to do is we'll just go for wood instead, because I think timber's probably not. Yeah, there we go. So these are more like proper timbers and woods for joinery. So we'll just do a white oak for our base finish. So if you just move that up into your project, now it's available as a project material, and you'll see now it's in that parameter value. For this, we'll just take a brass for the handle. I know there's definitely a brass in the Autodesk library, and this library comes with Revit by default, so you should have this available as well. The same library that I'm using right now. Great. And there's our brass. And we will apply a parameter to this instance-based one, just so it has a default value. Let's just use a laminate. We'll just pick a white laminate for the countertop by default. But remember that we want them to be able to set this to other options if they so choose, independently of the type. Not necessarily a practical use for it, but we're just doing it for convenience. Okay, so we'll just add a laminate. Okay, so we've got one type. Okay, so the next thing we need to do is add information parameters. So there's not a lot of information in this family yet, but there's materials. There you go. So now this knows how to look. So we're going to add a couple of really basic fields first. Usually I like to add some authoring fields. So I like to put these under text typically, make them type-based, and I usually lock them down with a formula. So I'll put my name, who made the family, just in case someone gets their hands on it from another company. At least they know that, it's not really theirs, and even if it is, here's who made it. I usually like to add a group as well, or a supply group as I like to call it. So typically on most projects, group 1 would be, I think, a builder supplied, builder installed, 2 is client supplied, builder installed, and 3 is client supplied, client installed. And it's a table, so the client will procure it and the client will get it themselves, so it's a group 3. Okay. And I don't usually lock that down with formulas because I like to be able to manipulate that one with Dynamo, for example, using a batch script. Okay, so we'll just add a couple more fields. So we'll add a code field. Now the reason why I add code, I'm going to put it under identity data, is because Keynote isn't necessarily the easiest value to work with. I've run through this in other tutorials, but there are limitations to how much a Keynote can do. It has very few parameters associated with it, whereas these are shared parameters. You can do a lot of things with them. But if you really want to use Keynote, you can put it in here and actually drive that code. Drive that code with a formula. And there you go. So you'll see as that changes, so will this as well. So that's one way to manage that. We might also put an image of the family in there as well. There you go. Keep in mind that however big that image is, that becomes part of the family's file size. So keep it small. Here I usually like to lock these down because the reference product is what it is. There's no need to change it. Type comments, sometimes you can put in the size if you want, because you may want to schedule the sizes based on type comments. URL, I typically put the website for the product. For now, I'll just leave it. Description is really, what is it? Okay, and cost, I think it's $4.99. So even though it doesn't show you $1, it's actually working in dollars there, so don't worry if you can't see the symbol. Okay, so now we've got a lot of information in this family. So the last thing we'll probably want to do is we'll want to add an assembly code and also an omni class. So assembly code, you notice it limits it by category. So if I pick furniture, it sort of limits what I can see, which is quite helpful. So we're just going to do furniture and accessories. And you'll see that populates the number there for you. And here we're just going to be a little bit more specific because currently it's not overly specific. And we're just going to do residential tables and cabinets. Okay. And then what we might do is just make one more type, just so you can see what's happening with type and instance parameters. So let's make another type, and we'll just do 900 wide by 600 deep by 730 high. And we'll just go 900 by 600 by 730. And you'll see as I change between these, see that they change. So the last thing we need to do is just go down and update our type comments as well. 600. And there we go. And you'll see that changes the size of our family as well. So it always previews the type that you currently have selected. So we'll just do a quick purge. We'll just do a save. Okay, so we'll just make a new project, and I'll just sort of demonstrate the family in use. Okay, so we'll just load the project in. I'll load the family into the project, sorry. Place it on work plan. Okay, so there's one of them, and if we make two of them, you'll notice that these are separate types, but they're still controlled by one type. And the reason why I categorized my parameters into other is that if someone came in and wanted to make edits, you can see it's nice and easy. They're all sitting together in one area, whereas the ones in other get pushed down the bottom, which is much easier. And you'll see some fields are being automatically populated now. The Omni class is there. The assembly description is automated by the assembly code. So you can sort of see the value of just clean parameter management as a result. And you'll notice too, remember that the tabletop finish was instance based. So notice the only parameter I have available here is this, because every other one, it's type based. And you'll see those other two parameters here. So I can actually go and actually change this to something different if I so choose. Let's go crazy and say we want a brass tabletop. And if I go realistic, notice that it's different for those. But if I create a new one of these, it's not brass. It's just that particular one that it applies to. Likewise, I can do the same for one of these. And you'll see that on an instance basis, I'm allowed to override this. So you can use instance controls to do a lot of things. In the next session, we'll actually look at using it to control folding the table sides up and down, just for visualization review purposes. You can see the power of just good family modeling, and obviously too, it's renderable as well because we put materials on it. So you will get a decent amount of fidelity out of the family as a result. Obviously those materials aren't great, but that's an Autodesk material. Okay. So that was today's session. It sort of ran through just basic parameter usage and some formulas. In the next session, we're going to go through some graphical settings for the family because we're not quite finished with making the family look good in all views. And we're also going to add some final touches. We're going to make the table sides fold up and down as well to finish off the family. So feel free to join me in the next session. Thanks for tuning in today, and I hope you got a lot out of the session. Feel free to leave any comments or recommendations or queries down below. And if you enjoyed what you see, feel free to follow and subscribe. Thanks. Take care. I'll see you on the next one. Bye.